All right, algebra kiddos, here we go. Going through the chapter 4 review, all about functions and the vertical line test and all kinds of great stuff here. So I know that this review sheet looks long, but that's just because so many of the questions, especially in the multiple choice area, have so many options and the graphs take up a lot of room. So let's start with number 1. Temperature changes throughout the hours of a day. Early in the morning, temperature increases slowly. That tells you something. At noon, the temperature rises sharply. During the afternoon, the temperature stays the same for several hours, and as night falls, the temperature decreases slightly. All right, so it's increasing and then increasing sharply. It plateaus because it's constant, and then it drops back down. And the one that best matches this one should be choice D. Number 2. Look and see if you can determine a relationship algebraically between these x and y values. If you do not notice that this happens to be times 6 each time, you can always plug in the values for x and y and test them to see what works. I hope that you would realize that after you test the first point, 1, 6, if you plug in 1, you will get 6 here, but that doesn't work for all of the points. Your final answer should be B, even though y equals 7x minus 1 works for that particular ordered pair. Number 3. All right, which situation is best represented? So look at your two data points or your input quantifiers here. You have time versus speed. So I'm at a constant speed, then I slow way down until I have no speed at all. And then I come back up, and then I keep a constant speed for a longer section of time. So you have to read through these and decide which one fits. A swimmer starts at a steady pace, slows down to a stop, yes, then starts up swimming again, but at a slower pace than when she first started. Well, that looks good to me, but you should always check the other ones. After a ball is thrown into the air, it falls back to the ground and bounces. Not that one. An airplane starts slowly on the runway. Well, then your speed would go from slow and then quickly takes off before finding a cruising speed. No. The car starts on flat ground and drives quickly up a hill, and then it keeps driving. Well, this indicates a stopping point there, so that doesn't work either. It is A. Next question. The video club costs $35 to join. Each video that is rented costs $3.50. Let V represent the number of videos. Identify the independent and dependent variables. Well, stop right there. Independent is going to be how many videos, because that will determine how much money that you're paying. So your dependent variable is the money, as it usually is. So when I look at this, I notice 3 of them have the videos as independent and cost as dependent. So I can throw A out right away. Now, the $35 is a flat fee. So there's no variable related to that. It's just 35 no matter what. And then, in addition to that, you're adding 3.50 times every video. And that one should be C. 5 and 6, this is function notation, and you are substituting a value of -1. So when I plug -1 in for x, I take -9 times -1 and then subtract 11. Watch these negative signs and your order of operations. You should get C, -2. On the next one, I'm saying please evaluate the function x at the value 1. -7 times 1 plus 3. -7 plus 3 is -4. That gives you a C again. Hey, look at that, C. Don't freak out when that happens. Trust yourself. Number 7. Express the relation for the math test scoring system 1, 2, 2, 3, 3, 5, 4, 10, 5, 5 as a table and as a graph? Well, I guess the first thing is take a look at what's going on here table-wise, and your domain or your x values are 1, 2, 3, 4, 5. So as I look here, this looks okay. This is not okay. 1, 2, 3, 5. That's okay. D cannot determine? No, it's a relation. Pretty much everything's a relation if you get ordered pairs. Then I should get 2, 3, 5, 10, 5. 2, 3, 5, 10, 5. 2, 3, 5, 5, 5. That looks kind of odd. I don't think that fits. 4 should map to 10. So double check the graph just to be sure. 1, 2, 2, 3, 3, 5, 4, 10, 5, 5. You should choose A. Number 8. Here's another one. When this scan doesn't look so good, but it should be when x equals a value of 2. And so when you plug this one in and evaluate the function at that value, here we go. You take f of 2, negative 4 times 2, and then subtract 6. Order of operations, negative 8 minus 6 should give you negative 14, which is B. On my scan, it doesn't look as good, but that is a negative sign. Give the domain and range of this relation. Now let me draw this in better because it's not as easy to see on here. And especially on your worksheet, it really doesn't show up. But this is a completely horizontal line between these 2 points. And so when you look at your x values are going anywhere from negative 3 to positive 4. So your domain goes from negative 3 to positive 4. Nope. Negative 3 to positive 4. Nope. Negative 3 to positive 4. Yes? No. The range, I only attain one y value. Everything is at negative 5, so it is C. Number 10, here's another one. Now this is a little easier to see. Take a look. On the x-axis, you are going anywhere from negative 3 to positive 1. Okay? Negative 3 to positive 1. Now I see that B doesn't work and D doesn't work. My y values, the highest point I achieve is a 4, and the lowest value I achieve is down here at negative 5. So my y values lie anywhere within this range, any real number between negative 5 and 4. Negative 5 and 4. Aha! Now the question is, tell whether it's a function. If you run the vertical line test and double check, drawing verticals through here, this does pass. It is a function. Choose A. Number 11. Now this looks really huge, but it's not a complicated problem. Here's a table of data, and Lionel has observed that traffic is getting worse and it's taking him longer to get to work. He records once a week the following data for several weeks. Graph a scatter plot using this data. So this is the same data, and you decide which graph matches this. Week 1, you're at 6.3. Week 1, 6.3. Yep, week 1, this is at 7. Throw that graph out right away. At 1, I should be at 6.3. At 1, I'm at 6.3. Alrighty, now keep looking to see between these two where is the problem. And as I look at these and you start checking through the rest of these, when you investigate the data point 5 and 6.5 minutes, 5 and 6.5 minutes, it's right there. 5 and 6.5 minutes is missing, so you have to choose graph A. Describe this correlation on this scatter plot if there is one. Well, this does look very tightly compressed. They look very, very much to be forming a linear positive correlation, so say C. It's going up. Data was collected on the average winter temperature and the number of days with snow of a random group of cities in the U.S. What correlation would you expect to see the average winter temperature and the number of days with snow? Well, think about it. If I put the temperature here, and I put days with snow here, think about it. Here's my temperature. As my temperature gets warmer, how many days would you have with snow when the temperature is really hot? You'd have next to none. But if the temperature was really cold, the likelihood of having days with snow would be higher. You can anticipate this would be D, a negative correlation. Number 14, state the domain and range. Here comes the domain. The domain is your input, your x values, 5, 9, 0, and -7. The range values are your output values, in other words, the y values, 11, 19, 0, and -13. If you're one of those people that goes crazy because it's not in numerical order, you can put it in any order you want. Range and domains are just lists, so the order does not matter. Same thing with this one, domain and range. X values are 1, 6, 0, and -6. The y values are 3, 13, 0, and -11. Graph this function, make a table, and please choose at least 5 values for the domain. I tend to stick with what I call the fabulous 5 and go from here. -2 times -2 plus 2. You should get +6. At -2, I get +6. Plug in -1. I take -2 times -1 plus 2. 2 plus 2 is 4. -1, 4. Kind of goes right where the actual number is there. Plug in 0. -2 times 0 plus 2 gives me 2. So I'm crossing the y-axis right there. Plug in a +1 for my x value. You get -2 plus 2, that's 0. So at +1, I'm at 0. That's exactly where I cross the y-axis. -2 times my x value of 2 plus 2. That's -4 plus 2, -2. At 2, I'm at -2. There you go. You get to choose. Technically, when you choose and you've got enough points here, you can connect the dots and extend your line. This will be a straight linear pattern, a linear function. Same thing with number 17. Watch these negative signs, people. Choose at least 5 inputs for your domain. Now, this negative sign out front is like -1 times whatever x is. So when I put in -2, that's 2 minus 1, which is 1. -1 times -1 minus 1. Oh, my goodness, you get 0. -1 times 0 minus 1 is -1. -1 times 1 minus 1 is -2. And you get -3. So at -2, we're 1, 1, 0, 0, -1, 1, -2, 2, -3. This also makes a nice linear function. Straight line, sloping downward. Use the graph of this function, f of x, to find the value of y when x is 2, and record your answer in this grid. Okay, so find when x is 2. Here's where x is 2. Go up until you hit the graph. I hit the graph right here. When x is 2, y is 5. I'm simply asking you to record in here a value of 5. Please make sure you color in the bubble on the grid. Number 19, you have to make the scatter plot. So here you go. At 3, you have a value of 6. Put a dot. At 6, we get a value of 9.5. Put a dot. At 5, you are at 7. At 2, we are at 5.5. At 7, we reach all the way up to 11. An input of 4 gives me 7.5. 8 gives us 12. and an x value of 1 gives you 3.5. There's what your graph should look like. Does a correlation exist here? Yes, it does. It looks very, very much like a positive correlation. As your values on the x-axis increased, your output or your y values also increased. All right, next, to determine the sequence, whether the sequence appears to be arithmetic, and if so, find the common difference and the next three terms. So I'm looking from here to here to here to here, and every single time I change by a decrease in 7. So is it arithmetic? Yes. Common difference is -7. The next three terms would be -34, -41, and -48. On 21, it's a little different. It says use this arithmetic sequence, 7, 5, 23, 31, 39, to answer these questions. Find the common difference, +8. What are the next four terms in this sequence? 47, 55, 63, and 71. What is the 22nd term? If you want, knock yourself out and generate until you get to the 22nd term. But on your worksheet, I put in this generic formula for calculating terms of an arithmetic sequence. I'll get it jotted down here for you. In this case, my common difference is 8. I am asking you to find the 22nd term, so I am looking for a sub 22, that term. A sub 1 is the first term in the sequence. That is 7. N minus 1, my n number is 22. This is when we were talking about going through arithmetic sequences. This is how many jumps you have to make to get from the first term all the way downstream to the 22nd term. You make 21 jumps. Every jump, you're increasing by 8, and we started at the number 7. When I multiply and crank this out, you will find that the 22nd term should be 175. The last part here is some vocabulary matching, and we get back to some of the terminology from the beginning of Chapter 4. A graph made up of unconnected points. Well, if it says it's a graph, that leads me to say it's going to be continuous or discrete. If they are not connected, that is B, discrete, just the dots. 23, the set of output values of a function or a relation. The domain is the input, the output is the range, D. A graph, again, made up of connected lines or curves, that's going to be A, continuous, connected. Number 25 says any old set of ordered pairs. Any old set is G, a relation. It's not a function unless each x value only maps to one y value. 26, the set of input values of a function or a relation will be F, the domain. So it goes B, D, A, G, F. All right, there you go. Your test, again, will look very much like this. So just practice reviewing from this sheet. Look back at your notes, look back at assignments, and you're ready to go.